Bismillah والصلاة ala Rasulullah, and welcome to everybody in this lab session about numerical method programming with Fortran. So in this presentation, I will give a brief introduction about numerical method and language programming. I will introduce you to Fortran languages. So let's begin. So just I will give you information of this course. Now, as you know, in our session at the class, we have 1 hour and a half hours of practical work each week. Attendance is mandatory. The absence without justification will result in student being excluded from the module. Two continuous assessment and final written exam. Just to notice that the two control assessment with quizzes in online, what will be in Moodle. So you have to, we have 4 chapters. So in each chapter we will have a quiz. As you know, you have also final written exam and the exam with the assignment. You have 50%, when you want to calculate your mark. So just to give you some information, so this online session will help you, will enhance your understanding about numerical method. So it's additional support for you, for students, to enhance their knowledge in numerical method programming with Fortran. So what's the lab objectives? So first, the presentation of usual and basic numerical method. Learn the basic programming using Fortran and implementing this method with Fortran programming languages. So these 3 objectives will be studied deeply, and in each chapter with a new method, we will try to program it with Fortran languages. So the first question that we should to ask, why we need a numerical method? Why numerical method is so important for physicists or engineer in general? So all physical phenomena are governed by complex mathematical equations such as partial differential equation. Those analytic solution is complex or impossible. So if we take a famous equation, differential partial equation of Schrödinger, so we know that the kinetic energy plus potential energy equal the total energy. So if we want to solve this equation, differential equation partial, it's not so easy. So with development of computers has allowed us to have effective means for solving this problem numerically. But there is some characteristic of this numerical solution, such as this solution are approximates, is not exact. We need calculation method, what we call in computer language algorithms, and the calculation error and stability. So just to fix this point, analytic versus numeric. So if we have such equation, analytic means that we have explicit expression, whatever r, we can derive CR, whatever r. But in the numerical case, we have just a numbers. So we have to fix r between a fixed interval, and we have psi of r in the same interval. So we have just a number. We don't have explicit expression. So let's move now to some programming concepts. And the question, basic question, what does computer do? And they do two functions and only two functions. They perform calculation and second store data. But is this enough? No, it's not enough because we have to develop what we call fast calculation method need to be developed. So, what does calculation means? To know what calculation means, you have to know what does knowledge mean. And we have two types of knowledge, what we call declarative knowledge. So we announce a fact such as the square number of x is a number y, such as y multiplied by y equal x. And there is imperative knowledge. How calculate the square root of x, and we have many methods to do that. I will just cite one method. It calls bisection method. So we have to choose between a number between 0 and x is in the middle. So we will check if y multiplied by y equal x. So it is okay. So y is there is square root. If not, we will test if y square is greater of x or y square is less than square, and we have to calculate the new y and do the test. This steps is called algorithm. And what does the algorithm mean? An algorithm is a sequence of instruction that describes a method or means to solve a problem. To execute to execute the instruction, we need a program called programming language. Example: we want to swap the content of two glasses. So the first glass contains juice and the second contains milk. And the solution to swap between them, we have to add an intermediate glass. So adding intermediate glass, we can solve the problem and we can write it in an algorithmic way. So A equal G and G equal L and L equal A. This is affectation. This is the solution of this problem. So we have to notice that the juice will be called the variable G, the milk will be called the variable L, and the intermediate glass will be called the variable A. So generally speaking, to solve a problem in an algorithm way, it's necessary to identify the inputs, identify the outputs, define the relationship between inputs and outputs, and we have to write the algorithm. So let's take the second example, the sorting problem. So we have a couple of numbers and I want to class them from the uh, from the from the last one to the greater. So we have many possibility. So we can have a selection or a fission. So this we can have many solutions to a problem. So observation: a good algorithm must obey three conditions. The sequence of instructions described must be exact and detailed. The algorithm must be efficient. The algorithm must be simple. Last example: if we had an ingredient and we want to do some reset, so we will have some algorithm from the beginning to the end. Just notice this algorithm is written in French to keep the example taken from internet. So language aspects. To execute the instruction, we need a program called programming language. So we have to transfer this algorithm to instruction written in language programming. So language accept have 2 points: set of primitive operations, mechanisms that combine these primitives. Characteristic of programming languages. So we have the primitive, which are variable, arithmetic operation, and so on. We have syntax, the correct writing of instruction. We have semantic, the instruction are syntactically correct, by that must be logical, has a meaning. We have two types of languages, what we call low level, using elementary instruction, example assembler. High level, there is two types: compiled, translate the entire program on once; interpreted, translate the program instruction by instruction. So in our case, we will do Fortran language. Is a compiled high-level language. The Fortran is formula translator, as programming language used primarily for scientific computing, invented in 1954. It is the oldest high-level programming language. So just I will give this is a simple example about a Fortran program that calculates the area of a circle. So this program is began always with the term program and is ended with the term end. So structure of a Fortran program. The Fortran program has many parts. The first part is program, as we should give a name to the program. And we have the part of declaration. We have to declare all variables used in the program. And we have the instruction, so the algorithm will be transferred to instruction, and we will have end of program. So this is a first presentation about our session. In the next session, I will introduce you to the language code blocks, and this is open source languages. We will use it as is a language environment where we program our program or numerical method on it. So see you in the next session. Assalamu alaikum.